Yes, good morning, my dear students. This is Lakshmanana, LN brand of chemistry. Good morning, all of you. Good morning, my dear students. Come to the live class. Good morning. Right. Good morning, all of you. Good morning. Good morning. Sunny not. Hello. Hello, my dear students. Come to the live session. Yes. So now we'll start valency cell electronic pair repulsion theory. So what we have to discuss in the valency cell electronic pair repulsion theory. So look at all of you. So here, valency cell electronic pair repulsion theory, what we're discussing. That is first one. Geometry or shape of the molecule. Geometry or shape of the molecule is completely depends upon the number of lone pairs or bond pairs present in the valency cell of that particular atom. So geometry of the molecule. Geometry of molecule, or we call the shape of molecule. Shape of molecule depends on valency cell electron pairs valency cell electron pairs. Remember, it's very, very important. Valency cell electron pairs present in central atom of molecule. Central atom of molecule. Clear? So here, sir, in case any molecule will be there like this, for example, ammonia is there. Ammonia. So ammonia molecule surrounded by generally 3 hydrogens are attached to the nitrogen atom. That means 3 bond pairs are there. Then one lone pair also is present. Lone pair also is there. So the shape of molecule is depends upon the lone pairs and as well as bond pairs which are present on the central atom. That is the meaning of first point. That is the meaning of first point. The second one, remember, lone pairs occupies more space around the central atom. Lone pairs occupies more space around central atom. Central atom. Look at carefully in the NH3 molecule itself. So these are the 3 bond pairs. The lone pair also is present. Surrounding of central atom, more space. Lone pairs occupies more space than that of bond pairs. So bond pairs kante kuda lone pairs ekkuva space ni occupy chestayi, right? The next, repulsions are present. Repulsions are present between. Repulsions are present between lone pairs is greater than that of lone pair bond pair than that of bond pair. Remember, it is also very, very, very important. Lone pair ki madhyana repulsions ekku untayi than that of lone pair and bond pair than that of bond pair and bond pair. To minimize the repulsions, electron pairs are occupies surrounding of central atom in the molecule. Electron pairs are occupies surrounding of central atom in the molecule. That you have to remember. Repulsions are present in between lone pair, bond pair also. The next, so that you have to take. Next one. So bond pairs, lone pairs, both if you observe. The bond pairs, lone pairs, both if you observe. These are the main depends upon the shape of molecule or geometry of the molecule in the central atom. So next, so double bond or triple bond, consider as a single bond in it. Double bond or triple bond. Triple bond, consider as single bond. Double bond or triple bond, consider as single bond on this, right? So next, so whatever the molecules are there in the valence shell electronic pair repulsion theory, that we have to discuss. So look at, so these are the main important points. What are those? Geometry of the molecules depends upon valence shell electron pairs, nothing but here lone pairs and as well as bond pairs. The next, lone pairs occupies more space around the central atom. The next, repulsions are present in between the lone pairs and lone pairs. Then after lone pairs and bond pairs, then double bond or triple bond, consider as single bond in the valence shell electronic pair repulsion theory. So how to find out the geometry of molecule by using valence shell electronic pair repulsion theory? So in the previous class, we are discussed, that is how to find out the hybridization. Anybody can say what is the formula for find out the hybridization? What is the formula for find out hybridization? Anybody can say? So formula for find out the hybridization, that is steric number, it is equals to then 1/2 into V plus M minus C plus A. What is V? Valency electrons in the central atom. M, monovalent atoms. C, charge of cation. A, charge of anion. So this is the formula. Just remember, this is the formula. So now come to the point. So here, in case The previously we are discussed only bond pairs when it is present in it. So now we have to discuss about both lone pairs and bond pairs when it is present in it. So both lone pairs and bond pairs when it is present in it. So observe it carefully. So first, in case if you take steric number, so lone pairs, the bond pairs, then as well as lone pairs, then geometry of molecule, distortion when it is present lone pairs. That means the shape of molecule, distortion when lone pair of electrons are present. So look at, so one by one we'll discuss. Sir, in case Z value 2 is there, then bond pairs are 2, lone pairs are 0. The geometry of molecule we are already seen, that is the central atom surrounded by 2 bond pairs are there. The geometry of molecule is linear geometry. Sir, here the shape of molecule also same. For example, if you take BeCl2 molecule, Be, then Cl, then bond Cl. Already we have discussed about the bond angle is 180 degrees in it. Bond angle 180 degrees. The bond pairs are 2 bond pairs. So there is no lone pairs in it. So 0 lone pairs, that's what I told. So in case Z value, if you got 3, Z value 3 is there. Z value 3 is there, bond pairs are 2, lone pairs are 1. Now the shape of molecule, observe it. The geometry of the molecule first. The 2 bond pairs, 1 lone pair when it is present. Geometry of the molecule, look at. So generally, the 3 pairs are present, then 2 pairs. So here, then third pair, then here, right? Third pair here. But third pair occupies the lone pair of electrons. So once if you come to the shape of molecule, then here you have to take only bond pairs. For example, central atom, take it as A, then bond pairs, so take it as B. The lone pairs, just you have to keep like this. That's it. So this pair we have to consider as bond. This is not involved in the bond. So these are the electrons we are calling non-bonded electrons. What we are calling non-bonded electrons. In between the bonds, bond angle is present. So what is the bond angle, So bond angle is then 120 degrees. So why, sir, 120 degrees? So because the actually trigonal planar, so here 120, then here 120, then here 120 we are expecting. But here, look at, this is valence cell electronic pair repulsion theory. According to valence cell electronic pair repulsion theory, in between the lone pairs and bond pairs, repulsions are present, right? So once here, whatever the lone pairs are there, in between the lone pairs and bond pairs, when repulsions are takes place, then bond angle will be decreases from, sir, 120 to less than 120. That means either 119 degrees or 118 degrees, like this it will be decreases. Sir, example for this SnCl2. So Sn, then 2 lone pair of electrons are present. then Cl, then Cl, like this. Clear, all of you? Right? Yes. Next one. Sir, in case Z value 4 is there. Z value 4 is there. Sir, Z value in case if you take 3, sir, only bond pairs. There is no lone pairs. At that time, how can you take a geometry of the molecule here? Geometry of the molecule. This is just assume it as central atom. Then bond pairs 1, then 2, then 3. This is the bond pair. Then this is the bond pair. Then this is the bond pair. So here, what is the bond angle, man? 120. Bond angle 120. The geometry of molecular shape of molecule both are same when there is no lone pair of electrons. So what we call this is the geometry trigonal planar. Trigonal planar. Trigonal planar. So of course shape of the molecule also trigonal planar. Trigonal planar. So what about here? So actually the geometry is trigonal planar, but if you come to the shape, there is no consideration of lone pair of electrons in the shape, right? So it will be there like this. So what it is? V shape or bent shape or angular shape we call. V shape or bent shape or angular shape we call. So this is we are calling V shape or bent or angular shape, V shape or bent shape or angular shape. So look at some more molecules. So in case Z value 4 are there. Z value 4 is there. Then what is the geometry of molecule and shape of the molecule? And what are the examples for these that we have to discuss? Yes. So in case Z value 4 is there. So once Z value steric number 4 is there, what is the hybridization? Anybody can say? When Z value 4 is there, what is the hybridization? Z value 4 is there, sp3 hybridization. I told that Z value 1 is Z value 2 is there, sp hybridization. 3 is there, sp2 hybridization. sp2 hybridization. Z value 4 is there, sp3 hybridization. Z value 5 is there, sp3 dehybridization. Z value 6 is there, sp3d2 hybridization. Look, my dear students, look at all of. So bond pairs 4 are there. The lone pairs when it is 0. Then geometry of the molecule, if you observe the central atom, look at the central atom. This is surrounded by how many bond pairs? 4 bond pairs. Lone pairs, is there anything? Nothing will be there. So what we have to take here? So look at here one bond, then here one bond, then here one bond, then here one bond. So each bond it contains one of the atom like this. Now the bond angle here 109.28 minutes. 109 degrees to 8 minutes. So look at this is the bond angle, the shape of molecule, the geometry of the molecule, we call it is tetrahedral. What we call tetrahedral. The shape of the molecule also same. What is that? Tetrahedral only. Tetrahedral only. So now here if you observe this, then example for this example is CH4 molecule. In the CH4 molecule, the carbon is surrounded by 4 hydrogen atoms like this. How many hydrogen atoms are present? 4 hydrogen atoms are present. 4 hydrogen atoms are present. Clear? Understand? Then come to Z value 4 is there. So bond pair of electrons only 3, then lone pair of electrons are 1. So Z value ante enti meaning? Bond pairs plus lone pairs both. Bond pairs plus lone pairs both. It is equals to Z value. So in the Z value, 3 bond pairs are there, 1 lone pair is there. So observe the same structure, same geometry, take it as here. So this is the central atom. Now how many bond pairs are there here? 4 bond pairs are there. Sir, one of the bond pair consider as lone pair. Lone pair, lone pair. Consider as lone pair. Remaining are bond pairs, bond pairs, bond pairs. Clear? Understand all of you? So this is, we call it is pyramidal geometry. Pyramidal. Sir, in this central atom, take it as A. Then surrounding atoms are B. Like this. One of the lone pair is present on it. The bond angle, in case if you observe in this case, with the same geometry 109.28. According to valence cell electronic pair repulsion theory, in between the lone pair and bond pair, repulsions are takes place. So once the repulsions are takes place, here the bond angle will be decreases in between the bond, in between the two bonds. So how much it will be decreases? Less than 109.28 minutes. That is nearly 107 degrees. Nearly 107 degrees. So that is what in the NH3 molecule. Example, NH3 molecule. The bond angle is less than 109, even if it is sp3 hybridization. So sp3 hybridization unnapatkino, the bond angle sir less than 109.28 minutes, because repulsions in between the lone pairs and bond pairs. Repulsions in between the lone pairs and bond pairs. So next Z value in case if you take, so Z value in case if you take the 4 only, Z value 4, Z equals to 4. Then lone pairs are 2, then bond pairs also 2. Lone pairs are 2, bond pair also 2. So now the geometry of molecule have to take like this geometry. Geometry of the molecule. Then bond pairs. Bond pairs. The lone pair of electrons. So here the lone pair of electrons. Now this geometry of the molecule is V shape again. Look at the only bond pairs we have to consider like this. The V shape or bent shape we call. V shape or bent shape, or one more I told, angular shape. What we call angular shape. Then example for this man. Example. So what I told, central atom is A, then surrounding atoms 2 B, then lone pair of electrons, 2 lone pair of electrons are there, 2 lone pair of electrons are there. So example for this is H2O molecule. So oxygen surrounded by 2 bond pairs with the 2 hydrogen atoms, then 2 lone pairs are present. Clear? Right? So now, so next, take it as Z value in case 5 will be there. Z value in case 5 is there. Z value 5 is there. So Z value 5 is there. The 5 are bond pairs, 0 lone pairs. 5 are bond pairs, 0 lone pairs. Geometry of the molecule. Look at the geometry of the molecule, how it will be there. So just assume it, this is the central atom. Central atom surrounded by 5 bond pairs. There is no lone pairs. Lone pairs are not present. Lone pairs are not present. So look at 5 bond pairs. How to consider? These are the 5 bond pairs. So in these 3 bond pairs are present. 3 bond pairs are present in one plane. In one plane, within the plane, 3 bond pairs are present. 3 bond pairs are present within the plane. Above the plane, 1 bond pair, and below the plane, 1 bond pair. So now we have to take it as trigonal bipyramidal. Trigonal bipyramidal. Trigonal bipyramidal. Trigonal bipyramidal. So now next, the example for this is PCl5 molecule. PCl5, phosphorus pentachloride. Chlorine, chlorine, chlorine. 3 chlorine atoms are present in the same plane. The remaining 2 chlorine atoms, above the plane is 1 and below the plane is 1. So what is the bond angle, sir? Sir, bond angle which are present in the trigonal planar. Trigonal planar which are present, that are 120 degrees. So above the plane and below the plane. Above the plane and below the plane which are present, that are 90 degrees. 90 degrees. So bond angles in this case, sir, 120 also is there, 90 also is there. 120 also is there, 90 also is there. So observe it. Next one. In case Z value 5 is there, Z value 5 is there. So bond pair of electrons are 4, lone pair of electrons are 1. Bond pair of electrons are 4, lone pair of electrons are 1. So look at the same molecule we are taking. Same molecule. So this is a central atom. This is central atom. Then surrounded by first 3 bond pairs I told. Then above the plane 1 bond pair and below the plane 1 bond pair I told. Here you have to observe this. One of the lone pair is present. Lone pair present అయినప్పుడు lone pair present అయినప్పుడు lone pair present అయినప్పుడు lone pair present అయినప్పుడు sir, one of the position occupied by lone pairs, right? One of the position. So here these positions are called equatorial positions, then axial positions. These 2 positions are called axial positions. These 3 positions are called equatorial positions. So remember, in the trigonal bipyramidal shape, then at this position, that means in the equatorial position, occupies the lone pair of electrons. Lone pair of electrons. So now the shape of molecule. So we call it as seesaw model. Seesaw model, nothing but seesaw model, nothing but. Sir, if you observe in the parks, so childrens they will play. So one person, they will sit one side, another person they will sit one side. This is look like seesaw model, right? So even this is also, when it is turned like this, so actually here lone pair is occupies. So when it is turned like this, the same thing. When it is turned like this, here bond pair is there, here bond pair is there. Then the here bond pair and here bond pair, here bond pair and here bond pair is there. Then the lone pair of electrons are occupies. This is, we call it as seesaw model. But it is seesaw model. Now Example for the seesaw model is SF4 molecule. SF4 molecule. So observe the SF4 molecule here. So actually first you have to find out the Z value for this. Z value 1 by 2 into. So valence electrons, how many total valence electrons? Sir, 16th group 6 electrons plus monovalent atoms are 4 minus C, charge of cation nothing will be there, charge of anion nothing will be there. So 10 divided by 2 you can get it is 5, right? So 5, Z value we got it is 5. So in this one is 4 are bond pairs, one is lone pair it would. So SF6 molecule, yes, sulfur will be there. Then 3 positions if you take, which are present in the same plane, So fluorines are occupies at this positions. At this position, lone pairs are occupies. Then here fluorines. So equatorial positions only occupies. But equatorial positions only occupies the lone pair of electrons. So in case Z value 5 only is there. Z value 5 is there. But the lone pair of electrons are 2. So look at the geometry of molecule. Z value 5. Lone pair of electrons are there. Z value 5. Lone pair of electrons are present. Bond pairs and lone pairs if you observe. So in case Z value 5, bond pairs are only 3, lone pairs are 2. Consider lone pairs are 2. So I told that equatorial positions only occupies the lone pair of electrons. The previous, when lone pairs are only one will be there, at that time at this position lone pairs are occupies. Now lone pairs 2 are there, right? So at that time, at this positions lone pair of electrons occupies. Atoms remove cheyandi, lone pairs ni occupy cheyandi. Lone pairs. Clear? Right. So now the shape of molecule, only 3 bond pairs are there. Look at here one bond, here one bond, here one bond. This we call T shape. T. So consider as this. Here one bond, then here one bond. The T shape. This is T shape of molecule. So example ClF3. The chlorine is a central atom. The 2 lone pairs are present at the equatorial positions. Then here fluorine, above fluorine and below fluorine like this. So shape of the molecule we call it a T shape. Z value in case 5 is there. The bond pairs only 2 are there. Lone pairs are 3. Bond pairs only 2 are there. Then lone pairs are 3. At that time, look at. Sir, the same geometry have to take central atom. Because why same geometry have to take? Because Z value is 5. So Z value is 5, nothing but 5 bond pairs are there surrounded by the central atom. Either lone pairs or bond pairs, whatever it may be. So all the pairs are present surrounded by that. So just assume it, this is the bond pair, this is the bond pair, this is the bond pair, and above the plane 1 and below the plane 1. So ఈ 3 atoms ఒకే plane లో ఉన్నాయి. దీన్ని trigonal planar అంటాం. Above the plane 1, below the plane 1. Trigonal bipyramidal we are calling. Trigonal bipyramidal. Right? Yes. So now these positions are occupying lone pair of electrons. ఈ positions లో lone pair of electrons occupy చేశాం. Lone pair of electrons are occupying. Now only these positions are bond pairs are present. So this we call linear shape. What we call? Linear shape. Linear shape. Example for this XeF2. XeF2. So look at the xenon. Z value, consider Z value, it is equals to. So 1 by 2 into xenon, 8 electrons. Then monovalent atoms are 2. Then how many? 8 plus 2, 10. 10 divided by 2, 5. So 5 Z value, right? 5. In the Z value 5, 3 are lone pairs, 2 are bond pairs. So 3 lone pairs are occupies equatorial positions. The remaining 2 positions are axial positions. When it is occupies, you can get linear shape. What is this? Linear shape. So next, in case Z value 6 is there. Z value 6 is there. Look at Z value when it is 6 are present. Then what are the molecules are there? How many bond pairs and lone pairs? Z value 6 is there. Then in case all bond pairs, 6 bond pairs are present, 0 lone pairs, just assume it. Now the geometry of molecule. This is the central atom. Central atom surrounded by 6 bond pairs. Assume it. So in this case, assume it. 4 are present in same plane. So like this, for example, in case if you take, so this is one of the plane. So all the 4 corners are occupies 4 atoms. So look at here one of the atom, then here one of the atom, then here one of the atom, and here one of the atom. So all are present in one plane. Then exactly above the plane and below the plane, atoms are present. So above the plane and below the plane, above the plane one atom and below the plane one atom, like this will be present. So this we call octahedral structure. So why we are calling octahedral structure, why we are calling octahedral structure, if you observe in the 3-dimensional manner, actually, sir, a square is present as a plane, like this, as a plane. Then above the plane one of the atom, just all the corners, just add it like this, once if we add 4 trigonals, you can observe. So here 1 2 3, one trigonal, then back side one trigonal, then this side one trigonal, and this side, look at here one trigonal. Then the below also 4 trigonals, like this. So this we call octahedron. What we call? Octahedron. So that's what we are calling it, is an octahedral structure. Example for the octahedral structure is XeF6. Sorry, SF6. So sulfur is central atom. Central atom surrounded by 6 fluorine atoms are present like this. 6 fluorine atoms are present like this. So now like this, the 4 are present in one plane, above the plane and below the plane. Here all are 90 degrees only. The bond angle are 90 degrees. Sir, in case Z value 6 is there, bond pairs are 5 are there, lone pairs are 1 is there. So that case you have to observe that here all are present in one plane. Then one of the plane, above the plane or below the plane, occupies the lone pair of electrons. Paina kani, kinda gani, above the plane or below the plane occupies lone pair of electrons. Then at this position one more bond pair. So 5 bond pairs, 1 2 3 4 5 bond pairs. One of the lone pair is there. This we call distorted octahedral. Sir, in case Z value Z value 6 is there. Bond pairs are 4, lone pairs are 2. Bond pairs are 4, lone pairs are 2. At that time, square planar we call. Square planar central atom. Then surrounded by that, the only 4 bond pairs are present. Then above the plane, 1 lone pair of electrons, and below the plane, 1 lone pair of electrons. Why these lone pairs are not occupies the equatorial positions, So in case if it is occupied above the plane and below the plane, so there is no any disturbance in the bond angle. So that's what. And minimum repulsions are present when it is occupies above and below. So this is square planar geometry. Square planar geometry. The clear? Then still the Z value in case 7 is there. Z value in case 7 is there. So Z value 7 is there. What is the hybridization, man? sp3d3 hybridization, right? sp3d3 hybridization. Z value in case if we got 7, then bond pairs are 7, lone pairs are 0. Bond pairs are 7, lone pairs are 0. Then the central atom, just assume it as this. Then bond pair of electrons, the 5 bond pair of electrons are present. So these are the 5 bond pairs. All are present in one plane. 5 bond pairs are present in one plane like this. Like this. Then the remaining 2 bond pairs, the 7 lo 5 ఒకే ప్లేన్ లో ఆక్యుపై చేస్తే above the plane 1, then below the plane is 1, above the plane is 1 and below the plane is 1. Pentagonal bipyramidal we call. Pentagonal bipyramidal. So look at in this case. So IF7 is the example for this. IF7 is the best example for this. So I is the central atom in it. Yes, I is the central atom. So F. So 5 fluorine atoms are present in one plane. 5 fluorine atoms are present in one plane. Above the plane, 1 fluorine atom, and below the plane, 1 fluorine atom, like this. Clear, my dear students? So this is about the valence cell electronic pair repulsion theory. Then after 10 o'clock, I will take one more class which is required for the previous year questions. Or otherwise, I will take evening class from 7 to 8. This is required for previous year questions for MSET examination. Those are present in the Andhra and Telangana. Then please subscribe my channel, share to your friends and those are preparing for the JEE mains and MSET examinations. Then every day morning and evening one of the live session will be present. So today evening, chemical bonding previous year questions I will explain to you people. Clear? Right. Thank you.